Okay, so I'm going to do number 69 from your review exercise. So let's look at number 69. So this is one of the problems where we can basically talk about different concepts. So I'll add one more part to it. So we'll see how to do that as well. So it says we have a ball which is thrown upwards, and when initial speed of 40 feet per second, and we have the formula, and they say use the formula. So that's h of t equals -16 t square plus v naught t, where v naught is our initial speed and h of t. So what do you think h of t is?
Right.
The height, right? So h of t is the height. And given this, we have to figure out when does this ball reach a height of 24 feet. That's part A. Then part B is when does it hit the ground? Part C says when does it reach the height of 60. So in the example there are only 3 parts, but we are going to add one more part to it, and that was the extra piece that I was talking about. Part D will be when does it means when does the ball reach the maximum height, and also a sub part to this one would be what is the maximum. So what do you think we want to figure out? We want to figure out the maximum, the time that it takes for the ball to reach the maximum height, and what is the maximum? What would be the other thing? We want to find the time.
In the maximum height.
Maximum. Exactly. Yes. We have seen these kind of examples when we discussed what? Parabolas. Yes, exactly. So let us see how we can answer all these 4 parts. Okay. So the first thing that we would like to do here is, let us draw a like kind of a picture for our reference. Okay. So for example, you are done with your finals and now you are playing with a ball. And you are trying to throw a ball. And if you throw a ball up in the air, how is the motion of the ball going to look like? It's going to look like a parabola. So it's going to look like something like this, right? So So you throw a ball, the motion is going to look like this. And when we have so the path that the ball takes, which is also called, in physics it's called the trajectory. So trajectory actually means the path that the ball takes, and in this case the ball takes the path which looks like a parabola. And whenever we have a path which looks like a parabola, we can represent that by what kind of equations? Quadratic equations, right? Remember, we can represent a quadratic equation by a parabola. Now, if we have a parabola, that means that can be represented by a quadratic form. Well, we don't have to discover that quadratic form. The quadratic form is already in here. So if you were in a physics class, in that class you have to first kind of derive this form and then answer all these questions. But in math class, we already have those formulas. Okay. So let us try to solve part A. What does part A say? It says
When it reaches like a height of 24 feet.
so when it says when does it reach? So what are they asking us for?
5 seconds.
The time in seconds when it reaches the height of 24 feet, right? So how are we going to set that up?
You plug in 24 or ht.
Exactly. So I should write negative 16t squared. What about V naught? Do we already have V naught?
Yeah,
What is V naught?
40 feet per second.
Because it specifies that the initial speed is 40 feet per second and V naught is our initial speed. So we are going to replace this V naught by 40. And as you correctly said, that the height h of t for the first case is simply 24 feet. So this equals 24. And our aim in for this equation is to solve for t. So how would we solve for it?
You would move 24 over to the other side, and then you could see if you could factor.
Okay, the first step would be to move this 24 to the other side and have 0 on the right hand side. Okay, the usual way of writing it in a standard form. So we have negative 16t squared plus 40t minus 24 equals to 0. And then after this, what would be the next step? Solve for t, but how would we solve for t? Yes, you want to say? Yes, we would either you can use you write this in a factored form, or we can also use quadratic formula exactly. But before doing that, we could simplify this. How could we simplify this?
You can take out an 8.
We could pull out 8. What is that?
The greatest common factor.
The greatest common factor. So we could pull out 8, or it would be better if we pull out negative 8. Right? We can also pull out 8, but with negative 8, then we won't have a negative coefficient in front of t squared. That usually makes our life easier, right? So if you pull out the greatest common factor, which is negative 8 in this case, what do we have in the parentheses? 2t squared. What would be the second piece?
Minus 5t.
Minus 5t plus
3.
So that equals to 0. So after this step, we have product of 2 equal to 0. That means this piece has to be equal to 0, right? So what do we have? 2t squared minus 5t plus 3 equal to 0. And in order to find t, we have to solve this. So I want you to solve for t. You can either use the factoring method or you can use the quadratic form. Okay. So try to solve this and then we'll move to the next part. I can see that most of you have already figured out t. So for this one, I prefer the factoring form. So the factored form. Anybody else use the factored form? Okay, so what was the factored form? T minus 1, 2t minus 3. And that equals to 0. Okay, and we have to verify that we get the same thing where we factor it. So it's 2t times t is 2t squared, and then we have negative 2t and negative 3t, which gives us negative 5t, and we have negative 3 and negative 1, which gives us positive 3. So this is the right form. So from this we can easily find t. So t from the first piece would be 1, and from the second piece t would be 3 halves. Well, 3 halves, we can also write 3 halves as 1 halves. Right? It's the same thing. If we have to write it in a mixed form. So that means we have t equals 1 second, and we also have time 1/2 seconds. So if we have to see it physically for the ball, that means, let's say it reaches a height of 24 feet. So the ball is right here. We reach 24 feet from the ground. And at that time, it takes 1 second to reach there, right? And why do you have one more time? What does that mean?
The other side of the curve, like hits like 24 feet, like coming back down.
Coming back down, exactly. So it reaches 24 feet from this side, and then it reaches a maximum right here, and then it moves down. So it's going to be at 24 feet above the ground at this time. So here the time is 1 second, and here the time is 1/2 seconds. So that was easy, right? To find the time when the ball reaches the height of 24. What about part B then? It says, when does it hit the ground? What does that mean?
When height equals 0.
When height equals 0. So you throw a ball up from here, it travels all this path, and then it comes down to the ground. So when it comes to the ground, the height will be, there's no height, the height is 0. So exactly height is 0, which means we again start with this form, the given quadratic form, and in this case, what are we going to replace height by? 0, simply 0. So we have negative 16 t squared plus initial speed is 40, and the right hand side will be 0. This is much simpler than this form, right? In this case, we can, how would we solve? How would we solve for t? Take out?
Negative 8t.
Again, do the same thing. Take out the greatest common factor, and the greatest common factor here is negative 8, but as well as
T.
t, okay, because we have a t squared and a t. We do that, what is left inside?
2t minus 5.
2t minus 5. So from this we have negative 8t equals to 0, or we have 2t minus 5 equals to 0. Well, from this we can get t equals 0, but that does not make any sense because we are throwing ball and it will take some time for the ball to come back down, right? So we are going to ignore that, but we can certainly solve for t from this piece. So from this, what do we have? T equals 5 halves. And 5 halves, we can write this in a mixed form, 2 halves. So that means it will hit the ground after 2.5 seconds. So if we have to write this in words for part B, ball hits the ground in What about part C?
And that's 16 then for h.
So part C is similar, exactly.